Okay, so for this video, we'll be looking at finding zeros when the leading coefficient is not 1. So let's take a look at this one. Okay, so let's go ahead and list the possible rational zeros. Of this. Oops. Okay, zeros of x, then we'll get plus minus 1, plus minus 2, right? If we get confused, we can just go ahead and put 2, 3, 4, 6, 12 over plus minus 1, plus minus 2, plus minus 5. Right? So we'll get plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 6, plus minus 12. And then we would also get plus minus half, plus minus 1, plus minus 3 over 2, plus minus 2, plus minus 3. I'm not putting them in because we already included them here. Plus minus 6. Then we get plus minus 3 over 5, plus minus 4 over 5, plus minus 6 over 5, and plus minus 12 over 5. Yes. And we get plus minus 1 over 10, plus minus 1 over 5. Didn't we put 1 over 5? Oh, we didn't. Okay. Plus minus 1 over 5, plus minus 3 over 10, plus minus 4 over 10, which would be 2 over 5. So that's already included. No? Oh no, I did a terrible job with this, guys. So I'm just double checking everything. Okay. 4 over 10. 4 over 10, so that is 2 over 5. All right. Plus minus 6 over 10, that's 3 over 5. 3 over 5, good. That's 6 over 5, good. So these are all the possible zeros. That's a lot, y'all. But so because this is a ridiculous amount of numbers, you could go ahead and we're getting some fractions, right? Because we're not just looking at integers this time around. So instead of, you can go ahead and try if you want to, but because it's going to be a lot of work for you guys. So instead, now is a time for you to use your graphing calculator. And if you don't have a graphing calculator, you can go ahead and use this website called Desmos. It's a very, very useful website. You can do a bunch of cool stuff. We'll be doing some projects using Desmos somewhere down the line, but you can just go ahead and you don't even have to sign up, I don't think. And then we'll just go ahead and plug in our function. So we'll have Okay, so I went ahead and plugged in my polynomial function into our software, and we get these different points. Now, if you're using Desmos, then you're really lucky because you can actually have a really easy time looking up the values. But you're not going to have access to Desmos when you are, unless I give you a special permission. It's expected of you to have your graphing calculator, even if you don't have it right now because you're only in 10th grade. When you're in college, let's say you're taking some college calculus or algebra courses, they're going to expect you to have a graphing calculator as the professor's going through their materials. So I suggest that you do get it. It's a good investment. But if you're forgetful like me and you don't really trust yourself, then maybe wait until you have a better hand on how to keep your things on track. Because as of now, I already lost my Apple Pencil and I don't know where it is. But anyway, so we can, and it's going to be hard for you to see when you're working with a graphing calculator, but what you can do is you can go ahead and kind of approximate what the x-intercepts would be in this case. So for here, I think it would be, it looks like it would be x equals negative 3/2, right? So that's 1, so about 3/2-ish, and then negative 1/2, because that's about half. And then we have, is that 3/5? Yeah, 3/5. And then we have negative, we have 2.562. 2.562, what would be the closest? I think it's probably 12/5, okay? So using our graphing calculator or Desmos, I went ahead and listed all these possible values of x. So now we're going to check them, okay? Let's try negative 3/2. And we're just going to be doing the same thing that we've been doing. So this would be negative 15, negative 26, 39, negative 3, 9/2, 63, 8, no, this would be 14/2, so it would be 23/2, and then this would be negative 69/4, and negative 21/4. So clearly this is not it. So let's move on to so let's try with negative 1/2 this time around. Be 10, negative 11, negative 42, 7, and 12. So this would be 10. That would be negative 5, negative 16, 8, negative 34, 17, 10, wait, no, 24, I'm sorry, negative 12, and then we get 0, bam. So we know that this is it, okay? So that means we can rewrite fx as 10x cubed plus 24, right? So from then on, we do the same thing where we try to see if we can factor this any further. Before we go ahead and use synthetic division again, what we can do this time around is first making our leading coefficients and constants smaller if possible. So as you can see, looking at every term, they all share the common factor of 2, so I'm just going to take the 2 out. this is it. Then I can go ahead and multiply that. So this would be 2x plus 1. The reason why I'm doing this is so that the numbers are a little bit manageable because it's kind of crazy, right? So I'll be doing the same thing. I'll be now looking at all the possible rational zeros. So it'll be plus, minus 1, 2, 3, 4, 6, 12. And then it would be plus, minus 1, plus, minus 5, right? So our numbers are not as bad, but it's certainly not as easy. So I'm gonna go ahead, graph this function. So this time it would be 5x raised to the power of 3 plus, no, minus 8x raised to the power of 2 minus 17x plus 12. Okay, so we have these 3 points now. So that looks like negative 1.562, 0.6 again, and 2.562. So it looks like, let's go ahead and pick the 3 points. One of them is 0.6 for sure, and that's easy enough. So I'm going to go ahead and perform synthetic division using 3 over 5. Then we get So we get negative 60 over 5, which is negative 12, so great. Okay, so we know that function of x equals 2x plus 1, 2x plus 1, and then x minus 3 over 5, and then we have 5x squared minus 5x minus 20, and again, we can go ahead and factorize 5 out of everything. So we get x squared minus x minus 4. And I'm going to go ahead and multiply this to here. So we get 2x plus 1 multiplied by 5x minus 3 over 5. So this would be just 3. And then we are left with x squared minus x minus 4. Okay, so we know that. We know that our function so far is 2x plus 1 and 5x minus 3 and x squared minus x minus 4. Okay. And now, let's see. Is this factored completely? We can go ahead and use our quadratic formula, right? So that would be our quadratic formula is negative b plus minus b squared minus 4ac over 2a. So in this case, our b is, so it becomes 1. Okay, so in this case, our zeros are zeros of fx, or you could say xr 1 plus square root of 17, 1 minus square root of 17, and then we need to have 3 over 5 and 1 over 2. Whew. So when you're doing, especially your extra credit work, I expect you to, because you'll be using your software or your graphing calculator, I expect you to at least try to roughly replicate the graph. So sketch the graph when you're doing the work, and then point out what the x values are.